Okay, so the first thing I want to do when we start talking about a program here is, and I'm not sure how many people did this. I know some of you guys were writing down like what signals turn on and off, but you should have this little flow chart, or what we call a sequential chart, or some people even call it a state diagram. But what signals cause what to happen. You really need this. This is your roadmap. And we're always talking about a roadmap. I know Peggy says you got to have some idea of what you're going to write before you start writing it. And the factory I/O, with you forcing on signals and then seeing what sensors go off and then what actuators you need to do, it makes it really easy. So you should start out with something like this. But when I went through it and I looked at it, and what I'm going to do for the start is when I press the start push button, I'm going to latch a signal called start process. And then when that signal is latched, and at the same time, because it's right there and it'll happen at the same time, as when I have the push button depressed and that start signal is latched, then that's when it'll send out that first box. So that's our emitter. Emitter turns on the conveyor. We get the pallet sensor, and then we turn that load signal on, which pushes it all the way in there. Now the pallet sensor isn't coincidence with the high and low sensor. Pallet goes first, then high and low. We latch in the height. When we get the loaded signal, then we turn on the output conveyor and the diverter, or the thing that makes it go right or left, and we turn off the entry conveyor and the load signal. Then when we get, and this exclamation point means not at entry, because the at entry signal goes low when it's actually there. So that negative means you flip the signal, so that'll be when the negative goes high, is when you turn the transfer off. And then when it's first at the at exit is when you turn the remover on. And then when the box actually disappears is when we say the remover is done. And then we shoot off a one shot, which does a few things. Number one, it turns off the output conveyor, but then it counts the box and moves the box to the accumulator into our output register. But then it sets off a timer, which that timer is going to put our second box on belt. So we go back to the emitter portion. And when that timer is done, we say that's the end of cycle, and all our stuff that has been latched, which pretty much at this point is only the remover or the timer, gets reset. Now, you can also put this into kind of a little timing diagram of highs and lows. And so this shows the start process, our first box, what goes on. And then we have these arrows that say this signal, the loaded signal, turns off the load and turns off the conveyor, but it also comes down here and turns on the transfer and the output conveyor. And so you can kind of follow these through. The only thing gets a little tricky is right at the end, because things are happening pretty fast and coincidentally. For the remover circuit, a bunch of people had problems with that. And so what I'm going to do is we turn the remover circuit on when it first gets at the exit, and then we latch that signal until we get our end of cycle pulse. So when that signal goes high again, that means the box is fully disappeared. And then we can say, okay, we've done removing the box, and now we can start our timer. So now the box is removed, and then we get our second box come on there. And this is really good for kind of, you know what states the signals are in from working with the factory I/O, and this can help you with the logic. This is going to be really helpful when we start, and if you want to get into the Siemens, because you can write something called structured language, which is kind of like the language you use in robotics. And when we get into Siemens PLCs, we'll talk about that a little bit more. So now we'll go directly into writing the code. And we'll take a break and be right back. We're going to put it in a bit, and we're going to make that as 1/15, which that's the first time through bit. And we always have that one available, and what we're going to do is we're going to move 0 into the integer that we have for the timer. And need that to be a colon. And we're just going to add the first few rungs, and then we'll go take a break, and then we can come to the end. So, well, I'm not going to show you every rung. It'll take too long, and I don't want to do that. So the first bit we have is the bit 8 is our start bit for the push button. And what we're going to do with that bit is we're going to run it through a one-shot, if my program allows me to do that. And for the one-shot, we'll just pick off a binary bit, and these are the inputs, the zeros, so we're just going to make the one-shot our first available binary bit, and then we're going to create a signal called the start process, and we'll give that binary 1. Well, that'll be our start pulse, and we'll bring that over, and then we'll put it in with the stop signal, and our stop signal is input 10, and that's our push button. Now this, we're going to latch around this. And we have to latch around the push around our start pulse because our start pulse is only going to be very short. And what we're going to do is we're going to create a start process signal, and we'll give that the next available bit that's available down here. It's our start process. And stay latched so long as we don't hit the stop button. So now our first one, and what we can do for these first rungs is we'll just put start process in there, so we don't have to put stop in there all the time. And what we're going to do is when we have the start process, and what we're going to do is our push button for the start, and we're also going to put in parallel bracket, and we're going to make this our second box, or every additional box beyond our first box. And what that'll do is that will be our emitter. And so we're going to make the emitter, and I have it set up because that's one of the bits we have to move. I'm just going to make it output bit number 8. And then I'm also, and you should, and I know Peggy stresses this, but you should probably put in, if you're going to use for bits, just use a separate bit. Let's see, this emitter bit will be our next available one. And so we're going to make that 4. And then here, you can kind of just copy this and paste it so we have our basic setup. And what we're going to do is we're going to put our emitter bit down here, and this will be our conveyor entry, so we just need to change that to bit 1, or bit 0 is the conveyor entry bit. And you can take a look at this description, copy it. This bit, we'll pick this one up as bit 5, and then when we put our latch circuit, we'll make this as our latch. So now we've got the emitter turns the conveyor on. We'll do the same thing. This is all just a big copy and paste, and after we do this one, I'll kind of give you guys a break, and then we'll come back and you can see the finished product. But now what we're going to do is we're going to, we've got the entry conveyor moving, and now what we need to do is we need to get that load signal moving. And that happens when our pallet bit, that's the wrong bit. Okay, our pallet sensor senses the pallet. And what we'll have there when the pallet sensor goes is we want to turn the load bit on. And the output load bit is bit 1. We'll make this guy the next available bit, which is load bit. So the load bit will latch in here. Now for both of these, we have what latches them in now. For this one and for this one, it's going to be the loaded signal, which is our capacitive sensor. And that is going to be the signal that breaks the circuit or interrupts the circuit. And that'll be that guy for both. So now we have it all the way to the front. Now we're just going to take a break and come back